Hi, really nice to meet you. My name is Philip, but feel free to call me Phil. I'm part of core faculty from Engineering and Technology Department at Auro EDU. Today, I'll be your guide and mentor throughout the course. Mastering Mobile Development, Android and iOS Careers. I'm genuinely excited to help you dive into the fast-moving world of mobile tech. Unlike the usual classroom vibe, think of this course as a hands-on, collaborative journey. And me? Not just your instructor, but someone you can rely on, ask questions to, and even geek out with over the latest app trends or tech launches. Here's the deal. This isn't just about learning how to build apps. It's about understanding how mobile development shapes every industry, from entertainment to healthcare, finance to education. You'll explore the tools, frameworks, and strategies used by top Android and iOS developers. And by the end, you'll be ready to not just follow the tech world, but lead it. Whether you want to build the next viral app, work at a big tech company, or even start your own thing, this course will give you the foundation to make it happen. So grab your laptop, open your IDE, and let's start turning ideas into apps. Let's build something incredible together. Evolution of mobile technology. Welcome to our session on mobile development. Let's begin by looking back. Mobile technology has evolved rapidly over the last few decades, from the bulky analog mobile phones of the 1980s running on 1G networks to the blazing fast 5G-enabled smartphones we use today. In the 90s and early 2000s, mobile phones gained digital capabilities. 2G brought us text messaging, while 3G introduced mobile internet. With 4G came HD video streaming and real-time GPS. The game changer was the iPhone in 2007, launching the era of smartphones and apps. Android followed, enabling developers globally to build apps that reached billions. Today, smartphones are mini computers in our hands, essential for communication, learning, health, shopping, even banking. Android versus iOS, key differences. Now let's talk about Android and iOS, the two platforms that dominate mobile development. Android, developed by Google, is open source and runs on a wide variety of devices: Samsung, Pixel, OnePlus, and more. This diversity gives developers a broad user base, but also a range of screen sizes and hardware to support. On the other hand, iOS, by Apple, powers iPhones and iPads. It's tightly controlled, offering a consistent experience and faster updates. iOS users tend to spend more on apps, but Android holds the lion's share of the global market. When you build an app, you'll often choose based on your audience, budget, and performance goals, or develop for both. Mobile versus web development. So, how is mobile development different from web development? Mobile apps are installed on a device and can access features like your camera, GPS, or Bluetooth. They can run offline, use native UI elements, and respond faster. Web apps, in contrast, live in a browser and are written in HTML, CSS, and JavaScript. They are easy to update, run on any device with a browser, and require no installation. But they're more limited when it comes to accessing device hardware. Mobile apps are ideal for immersive experiences. Web apps are great for accessibility and cost-effectiveness. Native, hybrid, and cross-platform apps. Next, let's explore 3 development strategies. Native apps are written in languages specific to iOS, like Swift, or Android, like Kotlin. They perform best and can access all device features. Hybrid apps use web technologies inside a native shell, like Cordova or Ionic. These are faster to build, but sometimes lag in performance. Cross-platform tools, like Flutter or React Native, let you write one codebase for both platforms. This approach is efficient, but still has trade-offs in UI precision and native access. Choosing a model depends on what your app needs to do and how fast you need to build it. Front-end versus back-end in mobile apps. Every app has a front-end and a back-end. The front-end is what the user sees and touches. The app layout, buttons, and animations. The backend runs behind the scenes. It stores user data, handles logins, and connects to servers. These two parts talk to each other using APIs, which are like messengers, sending and receiving data. Understanding both sides of the app helps you build better, more responsive software. Overview of mobile app architecture. App architecture is how you organize the parts of your app. The presentation layer is the user interface. The business logic layer handles decisions, like checking if a user is logged in or verifying a payment. The data layer deals with databases and APIs. Keeping these layers separate helps with testing, debugging, and scaling your app as it grows. SDKs and APIs. Think of SDKs and APIs as your developer toolbox. An SDK, or software development kit, includes tools, libraries, and emulators to build apps for a platform. Xcode is Apple's SDK. Android Studio is Google's. An API, application programming interface, is a bridge that lets your app talk to other apps or services. For example, Google Maps API lets you add a map. The Firebase SDK helps with login and cloud storage. Mastering SDKs and APIs is crucial in mobile development. Understanding app stores. Once your app is ready, you publish it to an app store. Apple's App Store has strict rules. Apps are manually reviewed. This takes time but ensures higher quality. Google Play uses automated reviews, so apps are approved faster. Both stores let you earn money through subscriptions, ads, or in-app purchases. Publishing requires following guidelines, testing your app, and preparing visuals like icons and screenshots. Tools of the trade. To build your app, you'll use IDEs, integrated development environments. Android Studio and Xcode offer everything you need: a code editor, a visual layout builder, a debugger, and more. Simulators help you test your app on virtual devices, so you don't need to own every phone model. You'll also use tools like GitHub for version control and Firebase for testing and analytics. Real-world mobile apps and impact. Mobile apps impact more than just your phone, they shape the world. During COVID-19, mobile apps were used for contact tracing, vaccine scheduling, and remote schooling. In developing countries, fintech apps help people without bank accounts send money or take loans. Education, health, finance, logistics. Apps are changing how societies work, and developers like you drive that change. App lifecycle and maintenance. Your job doesn't end when the app launches. You must monitor performance, fix bugs, and update for new devices and operating systems. Tools like Firebase or App Dynamics help you track crashes, slow loading times, and user behavior. Ongoing maintenance is key to long-term success. User-centered design. Great apps start with real people. User-centered design means designing with empathy, understanding users' needs and feedback. You test, learn, and improve in cycles. Accessibility is also vital. Apps should be usable by people with disabilities, older adults, and all kinds of users. Mobile app security. Security is non-negotiable. Apps deal with personal data, like emails, passwords, even payment details. Use encryption, secure login methods, and protect against threats like malware or insecure data storage. Follow best practices from OWASP mobile security standards. Performance optimization. Users delete slow or buggy apps. Keep load times short, minimize battery drain, and optimize for network conditions. Use profilers to measure performance. Libraries like Glide or Lottie can help with images and animations. Testing and mobile development. Testing keeps your app stable. Manual testing checks the look and feel. Automated tests verify logic and behavior. Use frameworks like Espresso, has Android, or XCTest, iOS, and track issues using Jira or TestRail. Monetization strategies. There are many ways to earn money with apps. offer subscriptions for premium features, sell digital goods with in-app purchases, or display ads using AdMob or Facebook Audience Network. Freemium models give users a taste and charge for upgrades. Cross-platform challenges. Cross-platform tools save time, but they aren't perfect. Maintaining a consistent UI across devices is tricky. You may need to write custom code for platform-specific features. Still, for many apps, it's a good balance between cost and reach. Mobile analytics. Data helps you grow. Track daily active users, retention, and how people navigate your app. Use tools like Firebase, Amplitude, or Mixpanel. Cohort analysis and A/B testing help you improve features and keep users coming back. Conclusion and future directions. So where is mobile going? AI will personalize user experiences. AR and VR will expand into education and shopping. Wearables and smart devices will require apps that go beyond phones. As a developer, you'll shape the future, building tools people rely on every single day.